Alors, la présentation suivante est de Marie Roucan de THEMIS. Pourquoi utiliser la RPE dans l'industrie?
Hi everyone, my name is Marie Roucan and I'm working for THEMIS company. And today I'm here to present you why should we be using EPR in industry. So THEMIS is a part of Antara Groupe. So Antara Groupe are experts in filtration solution. And it's divided in 3 parts. So the first part is axis formation and deal with training about the universe of filtration. Then you have Antara Group, who do the study and fund solution. And then you have THEMIS, which is more the technical part of it with the conception and the fabrication of products and the laboratory. So we have one lab analysis lab and one research lab. So the research lab, there is 3 axes of development. The first one is the improvement of oil analysis monitoring. So we use different techniques to monitor oil analysis. And we also implement new devices such as the TAN, the TOST, the CPA, and the new one was the EPR. The second axis is the improvement of the filtration technique. And the third one, the study of the degradation of oil. So why is THEMIS using EPR and what this technique can bring us? Well, it's especially to study the degradation of oil. And to do so, we start by simulate the oil degradation. And to do that, we put in place a lab scale reproduction, which reproduce what's happened in an industrial system, like a real system in an industry. And to do this industrial scale, reproduction of industrial scale, we use filter, we use pumps, we use actuator, and we degrade the oil following some normative and standardized process. So once the oil are aged, we are looking for so we are doing EPR analysis, and so we are looking for the free radical in the oil. And these free radical, they can be assimilated to a sort of quality indicators, and this quantity of quality indicators can lead us to the degradation stage of the oil, depending on the amount, depending on the type. The advantage of this technique is you can correlate this technique with the routine analysis we do every day in the lab. So, because as I said, we monitor the oil degradation, we do that with different techniques, and the EPR help us to understand what we can't understand with the other techniques. So this is really nice. So for example, in the oil, you have additives. These additives, they degrade as well. And thanks to the EPR technique, you can see the different degradation of the additive, for example. So depending on the stage of degradation of the additive, you have different additive free radicals. And then you can see at what point of the degradation of the additive you are, and you can correlate it with an analysis we do very often in the lab, which is called ruler. I'll tell you the amount of the type and the amount of antioxidants you have in your oil. Then what you can do also is you can use it as a sort of treatment follow-up. So for example, you have a client who have a problem with an oil, and then you take a sample, you do your EPR analysis, and then you see different free radicals and big amounts of free radicals. And you said, okay, let's put a treatment in place to reduce and to clean this oil. Then after a few weeks or a few months, you take another sample. And this sample, you do an EPR analysis as well, and then you see, is the type of free radicals change? Does the amount of it have been reduced? And if yes, well, then it's great, because that means our our treatment is working. And if not, well, that means we have to change the treatment. But yeah, and so you can do that, and you can go on as well, because you can keep taking EPR samples, to do EPR analysis, and see if your treatment, how long this treatment is working, and if at one stage you need to adjust your treatment. Another thing is, with EPR, you can do a visual study of the oil degradation, because you can study liquid and solid samples. So for example, we can do analysis on oil samples, and which show you what appear in the oil or what disappear in the oil after a treatment. But you can also do EPR analysis of different filtration systems. So for example, membrane, where you got a residue, but also the filtration system itself. And you can see what has been retained from the oil. And then you can also do analysis of the residue, and the residue is basically everything which crashed out from the oil. So this is really interesting, because you can see the whole picture of the oil degradation. Then a third advantage is the technique of the spin trap. So when the oil degrades, you have different types of free radicals which appear. You have the long-lived radicals, and you have the short-lived one. So the long-lived radical, it's fine, because you take your sample, you prepare the sample for the EPR device, and then once you do the analysis, because it's a long-lived radical, you can still see it on EPR. For the short-lived one, it's a bit more tricky, because they disappear very quickly. They are really reactive, so you can't really see them if you do it the same way. So we use the spin trap technique. So you use a molecule, for example, the DMPO here, and you can use many other ones. And this spin trap doesn't have any response in EPR, but once it's linked to a reactive oxygen species, for example, you can see the response in EPR. And this response depends on the type of reactive oxygen species you've been trapping. So yeah, so for example, here you have in yellow the oil without DMPO, and in blue the oil with DMPO, and you can see the response is not exactly the same. I mean, we've been trapping something. Then this was all the techniques, all the things we could do with the EPR we have in our lab. But from this new implementation of the device, we also put in place a collaboration with InfraAnalytics. And this is the most important part of the EPR project, because this collaboration allowed us to have access to team working, especially Hervé Vezin and his team. And this is important because they help us and they guide us through this implementation of the new techniques. And they allowed us to investigate things we couldn't have been able to investigate by ourselves with the analysis we had before. The other thing is they have more powerful equipment than the one we have in the lab. So this equipment allowed us to do other type of analysis. And for example, here you have a kinetic studies. And this is nice because you can see on a short period of time or long period of time, you can see what happened to your oil, and you can monitor it minutes by minutes or second by seconds. And then you can see how the oil evolves depending on, for example, the temperature. And you can do high temperature or you can do low temperature. This is really interesting. And we can't do that with the one we have in the lab. The other thing we can do is imaging. And this is really interesting because this type of image shows you the distribution of the free radical. So for example, you have a membrane with a lot of residue on it. And then you put it in, you do an EPR analysis, and then you have this kind of image you see on the bottom of the slides. And it shows you the distribution, where are the radicals, depending on if they are organics or if there is all of them, metallic and organics. So this is something we are able to do thanks to the collaboration with InfraAnalytics. And what is nice with all this collaboration and the implementation of the EPR analysis in our lab is we can prevent, treat, and improve. By that, I mean we can prevent the future problem and the measure to come. We can anticipate the treatment before the problem starts. and we can improve the filtration and the treatment system. And this is really nice because by anticipating the degradation of the oil, we can increase the lifetime of this oil, but we can also decrease the carbon footprint we have. So this is really interesting, and this is due to the addition of the EPR technique to the panel of analysis we have. So, and I think we are using it for oil degradation, but this is a technique you can easily use for many other type of application. Yeah. So thank you very much. And I will go.
Alors, y a-t-il des questions dans la salle, ou English ou French pour Marie Roucan?
En French.
Whatever.
Est-ce que vous regardez aussi le contenu en métaux dans les huiles qui ont été utilisées? Parce qu'il peut y avoir des corrélations au niveau de la formation des radicaux, notamment parce que les métaux peuvent participer à de la catalyse.
Oui, en fait, donc du coup, bon, la RPE nous permet de voir les radicaux libres métalliques. Et en fait, cette analyse est aussi corrélée avec des analyses ICP qui nous permettent de voir la concentration en fait en métal qu'on a à l'intérieur de nos huiles. Donc, on arrive en fait avec tout ce panel d'analyse à corréler en fait ce qu'on voit en ISR et du coup ce qu'on a nous dans notre huile en termes de métal.
Non?
En ligne, have you done any NMR of the residues?
No, not so far. Maybe at one stage, that's something we think of, and that's a good thing. Thank you. We might at one stage, but for now, no.
That was one of my questions, but many more general question about how did you go to EPR? What was how the initiative arrived?
I think I will, for this question, I will let my Jeremy Pallas to speak. He will be more.
Thank you for your question. The idea provided a long time ago when we're looking for, it's a little bit the same idea as the previous speaker from Cooper. So there existing some normalization analyzed with ASTM or ISO and so on. So the thing is there are a limit of this analysis to have a prediction and to really understand deeply what happened with the additive in the oil, and is existing also a lot of different kind of oil, lubrication oil, I mean. And by looking on the paper, thesis, and so on, we find some interesting scientific information from other field, more or less from cosmetic and we start to the path to look to this analysis, and the project was very appear when we start to have a good contact and linked with the infranalytic. So that's one of the real points. It's the partenariat, and I heard some word here, partenariat, and I saw also true, and that is very important. It's a team, it's an adventure with you.
Thank you very much.
You? Thank you very much, Marie Roucan.
Thanks. Thank you very much.